Yeah, go ahead.
Okay, so now I'll go ahead and share my screen. Okay, so can you all see the screen?
I would go
Yes,
ahead and
please.
hit
Yes.
slideshow.
Yes, okay. Okay, so for our final project, we did a multi-factor authentication with an offline ATM. Okay, so here's the problem that we're dealing with. So today, bank ATMs, they are connected to the online bank server, which contains all the clients, their account information. And if someone steals your, say, your ATM card or your debit card, and they know your PIN number, they can basically use the card and your PIN number to access your account on an ATM, and they can basically withdraw money from it, even though they are a different person. And so we decided. So our proposed solution to this is to use a multi-factor authentication to add an extra barrier of security to ensure that this doesn't happen. So multi-factor authentication is already used for emails. For example, if you were to log into your email on another computer, they may send you a code on your phone to make sure that it's actually you. And so we thought that it will make sense to also use this in something like finance and banking. So our multi-factor authentication scheme, it involves an ATM that's not connected to the internet. It's offline. It's like a remote. And we also have a separate online bank server. So what happens is the client first goes to the ATM. They provide their card information, like account information, as well as their PIN to the ATM. And then after that, they will also receive a code from the online bank server. And they will have to enter that code into the offline ATM in order to gain access to their account. Now, what happens after this transaction is approved is that the offline ATM will update its own transaction log that's separate from the online bank server. And so since the ATM is offline, the log that it updates cannot be tampered with. And also the online bank server will update the client's account information separately. And we can ensure that the online bank server's updates are consistent with the offline ATM's updates by consistently checking the bank server with the offline ATM log. And what this will result in greater security and transparency to ATM transactions.
Okay, so this is our project diagram. I don't want to get too into the details of this because we're going to demo it anyways. I just wanted to point one thing out specifically. We spent a lot of time architecting this design. We know that it's finance, so we know that the client shouldn't get cheated out of money that they have, but we also know that the banks also shouldn't be cheated out of money that they also have. So we differentiate in our diagram. We see steps 6.5 and 8.5. So importantly, when a client is withdrawing from the ATM, in order to prevent the client from abusing that PIN and withdrawing multiple times, one, we make a stale PIN, but two, we also make sure that the bank server, once it's sent out that MFA PIN, that it updates the client's logs. If for whatever reason the client doesn't withdraw after that log or after that PIN is released, then they can compare against the ATM log and get that cleared up. However, on a deposit, the acknowledgement comes up from the client after they've made their deposit because they're incentivized to make sure that that bank server is updating the money that they've deposited. So in this way, nobody should be cheated out. It should be consistent, and there shouldn't be any way for the system to be abused. So I think we can go in the demo now.
Okay. Okay, let's see. So I have 3 windows up here, and first I'll go ahead and show you guys the files of our project. So we basically have two main classes. We have the person class and the bank message class. Now the person class basically contains each client's account information, such as their name, their PIN number, and the amount they have in their account, like the amount of money they have in their account. And the bank message basically contains like whether the client wants to do a withdrawal or deposit, and also the amount they want to withdraw and deposit, and this as well as the PIN number, and this will basically be the message they send to the offline ATM to start the process. And so over here we have, let's see, we have one client, the project client, which sends the messages, and then we have 2 servers, the offline Bluetooth ATM and the online bank server. So I'll go ahead and get these 2 servers up and running. So I'll start the Bluetooth ATM first. You see the object has been created, and then I'll do the bank server, and that's been created. Now we can go ahead and run the project client, and this will generate some output.
Okay, so I'll explain the output, but I also wanted to point out the reason we named it Bluetooth ATM as well is because we were trying to show that there is some sort of non-internet based communication that's happening between the client and the bank ATM. But as we went through the project, we realized they could just physically do it. So it might be named a little bit confusing. So just think of it as like a normal ATM. So
no, I think Bluetooth is a great one because if you have Bluetooth in the future, you might not need this kind of physical ATM machine at the bank, but you can just put like a Bluetooth access point for you to access it might be even more secure. Oh, well, I guess we cannot do that because ATM, they have to have ATM because they need to split out cash.
You get the money, yeah. And then we figured that Bluetooth might have some security
Right.
vulnerabilities. We weren't sure, so we're like, we'll just do it physically.
Right. But in the future, you go to the bank, you might not get a cash, but you get like a cryptocurrency or something like that. Yeah.
There we go.
Yeah.
So I'll explain the message output. So we wanted to show the versatility of our design with these with these outputs. And so the examples that are incorporated are a successful withdrawal, and then several failures, one due to wrong PIN, one due to insufficient funds. And then we wanted to show a successful deposit, but we also wanted to show during that deposit scheme that a second operation will fail because they're going to be reusing a code they've already done to demonstrate that they can't abuse this system. They can't deposit multiple times. So Franklin, if you could go to the top. Okay, so the first sentence or the first output, we're sending a message to the ATM. It notices that it's a withdrawal action from a client named David Jacobs in the amount of $130. And it also generates a timestamp. So it forwards that timestamp to the client, which then forwards it to the bank server. So the bank server is the one that's going to be checking, oh, is David Jacobs a person inside of our bank server? Do we know who he is? What's his account balance? And does he have enough money to make this withdrawal? So in this case, the bank server received this acknowledgement, it understood or it authenticated it. And so it sent the MFA passcode to the client. And as soon as it does that, it's going to get, as soon as it knows that that MFA code has arrived at the client automatically, it's compulsory. It has to send an acknowledgement to the server. So the server will then automatically withdraw $130 and update the new balance of the client. And then this last one is just our debug where the ATM is saying that David Jacobs successfully withdrew $130 with no error. And so we also have a function that we can print out the log that's being stored on this ATM. So we can see that David Jacobs with this PIN number withdrew this amount. So if we scroll a little bit down, so then we have several failure test cases. So Hank Aaron is trying to deposit $50. However, he provided the wrong PIN. So it just stops dead in its tracks there. He can't do anything else. Then we have Hugh Grant trying to withdraw $200. Well, Hugh Grant has insufficient funds, so it's just stopped there. He failed authentication. Here, as the last one, we have a deposit from a woman named Melissa Thomas in the amount of $1,000. So she authenticated it. The server, she was authenticated on the server sent her a passcode. She successfully entered that passcode and deposited the $1,000, which is updated in the ATM log. However, this user tried again to deposit that $1,000 with a similar PIN, but it's going to say it failed because the PIN is no longer valid. It's a stale PIN. And so after that, Melissa wants credit for her deposit. So she sends an acknowledgement to the server, which reflects that she has now deposited $1,000 into her account. So that's the full demo. And we have one more slide. So while we were going through this, we realized like the bank server ATM, like that might be a little bit limiting. Why stop there? So we think that, you know, we could extend the scheme to like credit card purchases. So, I mean, that's much easier to steal. Someone can just steal your credit card and swipe it. There's not even a PIN that's involved there. So why can't you have like a duo push that you're accepting on your phone to make sure that these transactions go into place? Because credit card fraud, I think, is a lot more common than somebody stealing your bank ATM or debit card and entering the PIN. Other than that, you could also do identity verification when you're renting items or traveling. You're authenticating on a server from an offline node. But the whole idea behind all these different things is consistent, is the idea that it's your data. And so you should have control over it. You should be the primary access gateway for anything involving your data, essentially. And that was our project.
Okay. This is great. I want to, let me see. Do I have any question? I think your scenario, both the ATM as well as the credit card, they're both very good example. I totally agree with you that the idea that you're working here has a lot of potential for the future financial industry. I mean, one of the things you mentioned about the credit card, I mean, this is the same as ATM as well, is that typically today, a lot of credit card fraud is because we're using the credit card online in a way that if anybody grab our number, they will be able to use it over the internet. Right. But it's not that hard if I have a little bit verification about my physical presence with this car, then it will kill a lot of this kind of bad transaction. It will be totally different from those hacker has to work really hard to actually get it to work. Yeah. So there is. I have actually one question and one request from you guys. Let me go with the question. So there is another scenario, which is so here your presentation, assuming one person, I'm the holder of the ATM card. I'm actually going to get the money. It could be another case, which is I actually have a proxy. So I'm actually in say South Africa, and say Franklin, I trust you. You're in Davis. And the thing is that I want Franklin to help me to actually be able to get some cash, to do something for me. And I think that scenario basically need to set up such that I need to prove it's not just multi-factor, but it's actually multi-person. That indeed this is Franklin Kong, this is a Felix Wu. We're actually both online at the same time. We can actually do that. Yeah, I think that's definitely. If we extend that, that's actually pretty cool, because that means we can actually access our money even though there's no Chase Bluetooth around
Yeah.
in South Africa. Yeah, that's my I think you just don't have time. Because if you have a time, you can actually extend to that. That
Sure.
lead to my request. I'm actually interested to if you agree, number one, I would like to extend your work and your code for two reasons. Number one, I feel that the idea itself could be extended to be a interesting academic work about a paper or something. That's number one. And number two, I feel the way you're programming, you're using the C++ JSON RPC, because I'm actually teaching an undergraduate course, ECS36B, in the fall. I'm actually trying to motivate the student to look at some example so they will be able to do some kind of small project along the way. So I feel your idea and your code is actually a good helping for them to be able to understand, appreciate the concept, and then they can probably build something and to continue develop that. So the second one is purely a request. That means, I mean, unless you agree, I mean, you don't have to say yes or no right now, but I feel your work is definitely have some potential. You can move because I like the work you're doing because your application scenario is so clear and is so doable in the short term, in my opinion.
Right.
So it will be good for us to. I don't know whether you guys want to start your own company, and my concepts or academic. We can release some idea and then push the publication and push somebody who might want to land on those ideas to actually be able to help our financial industry. I mean, help security in general. Yeah.
Sure.
So just to let you know that. I don't have further question, and I think you guys did a great job, and I appreciate your work. So do you have any question for me?
Well, so beyond the request for 36B, I don't have any problems with it. I mean, Franklin, do you have any problems?
No, not really.
So if there's no problems, how would you like us to transfer our code base to you?
Yeah.
Just like
So I like to do two things. I mean, of course, you can just send me a tar file about your code, but I think I would like to go beyond just taking the code from you, and I would, because this idea will need to be further developed. So number one, put your name in the README file to make sure that you're the originator. And the thing is that if we develop any publication, any idea, we will actually like to contact you to be included, to be invited as a co-author, and to actually continue to work on that. By the way, I just want to check, are you a master's student or PhD student?
We're both master's students.
Yeah,
Okay,
masters.
okay. So is this the first year or second year?
It's my first year.
For me, it's second year.
Okay, okay. So hopefully before Franklin you graduate, we'll be able to submit the paper. Okay,
Okay.
and I think we
Yeah.
can make it for Francesco. Okay.
Woo!
Yeah.
Yeah. Okay. All right. That's great. Okay. Thank you very much. And I'm going to. And by the way, because of pandemic, I should say welcome to UC Davis.
Oh, thank you.
Thank you.
Okay.
Yeah.
So, okay, I'm going to stop the recording, and then I'll just probably take a 40 minutes break, but I will keep this thing online here for next group at 11 o'clock. Okay.
Okay.
All right. Thank you. Thank you, Francesco. Thank you, Franklin.
Yeah.
Great
Thank
job.
you. Bye.
Have a good one.
Bye.
Bye.